In this video we're going to look at methods of factorising, and the first one we're going to start with is just your ordinary old common factor. So this particular expression contains two terms and we need to find the common factor to both terms. You'll notice that from a number point of view 3 is common to both. From a variable point of view, the a and a b is common to both, and that's the highest degree common factor we can pull out. So what times 3ab will give 3ab squared, and that will be b. Subtract what times 3ab will give 9a squared b, and we need a 3, that will give us 9ab, and an a will give us what we're after. So, going to the next question. The question's given us a hint as to what to do. It says factorise by finding a grouping factor, and although it can vary, a grouping factor is often a binomial factor. So we need to look at pairs of factors, pairs of terms that will give us a common factor and hence a grouping factor. And this one's in, I think, we'll double check, a good sequence to do that. If we look at the first two, there's a common factor of x, and the other factor will be x take 1. Alright, that's just from the first two. Then if we look at the last two terms, you'll notice that y is common to both, but we'll take minus y out as a common factor, which means that minus y times what gives minus x, y will be x, and minus y times what gives plus y, it'll be minus 1. So you can see that the grouping factor that we've obtained here is x take 1, which means that the other factor, if we take that out the front, is x take away y. Okay, we have another question here. Once again, 4 terms. There's a couple of different options to how to deal with 4 terms, but there looks to be a grouping factor set up here because you can see we have a difference of squares to begin with and predict that one of those factors will be 2a plus b, and then we can draw a 2a plus b factor from the last 2 terms. So treating this as a difference of squares, we know this is 2a minus b and 2a plus b plus, now it would be nice to write this as a factor so that we can distinctly see the grouping factor. So I'm going to write that as 1 lot of 2a plus b. So what you can see now is that we have a grouping factor that's common to both parts, which is 2a plus b. So that then leaves, from the first term, it leaves 2a minus b, and plus 1 from the second term, which can be tidied up, so that's 2a plus b, and we will get 2a minus b plus 1. Now this time we've just been asked to fill in the missing factor. This is factorising a trinomial, and we're just going to, it's partly been done for us. It's really just checking that we understand some concepts about trinomials. And we know that the 2 first terms, this term and this term, must multiply to give x squared, so this must be x. And we know that the 2 last terms must multiply to give negative 30, so this must be positive 6 or plus 6. Now what we should do is perform a little check here, and I have an affectionate name for this middle term. I call it the smiley face term because it comes from multiplying those two and multiplying those two. So when you multiply those two, you get minus 5x, and when you multiply these two, you get plus 6x. The end result of those is minus 5x plus 6x is x, which is exactly what we should get. So there's no doubt that that missing factor is correct. Now, factorising this trinomial, you can do this two ways. I'm going to do it the sequence of steps way because it always works. It's just a matter of learning the method and following it. But there is also a logical way, and I think that for simpler examples that is better. So for the sequence of steps way, we need to go AC. These coefficients are A, B and C. So AC is equal to negative 20 and B is equal to negative 1. So what we're after, the reason for doing this is we're after two numbers that multiply to give minus 20 and add up to minus 1. And you can tell that 5 and 4 will do that. They'll multiply to give 20, and you can tell that there'll be a difference of 1, but one's got to be negative, one's got to be positive. So it will be negative 5 and positive 4. Now, the reason we did that is because we're going to rewrite this trinomial now, but instead of having minus x in here, we're going to replace it with minus 5x plus 4x, take away 10. That was the purpose of doing this this work on the side here with A, C and B. Now it just becomes a grouping factor type question, and for the first two you'll notice that x is our common factor, which leaves 2x take 5, and 2 is common to the next 2, which leaves 2x take 5. Now, if after doing that, the binomial factor, the factor that's in the brackets here, isn't the same, that means you've made a mistake and you need to work out what that mistake is. In this case I haven't, so we'll just proceed. So the grouping factor is 2x take 5 and the other factor is x plus 2. Now one more to factorise. This one's actually a difference of squares. So we're just going to use the identity for that. We know that a squared minus b squared is equal to a plus b, a minus b. The order of those two binomial factors is unimportant. So we've recognised here that this is 2a all squared, subtract 3 squared. So our answer is 2a take away 3, 2a plus 3. Now we're back to an expression that contains 4 terms, but this one's different to the others. The others that we did earlier had a grouping factor. This one doesn't. You can see looking at this that this is a trinomial that is a perfect square. Hopefully it's a perfect square. It's x plus 2 all squared minus y squared. Now I need to do that because of the length of the video, but that is a perfect square. So now we have a difference of squares and we can apply the difference of squares identity, which is a plus b, a minus b. So this is our a, this is our b, so it becomes x plus 2 plus y and x plus 2 minus y. Now I've put in nested brackets here because there are occasions when you do need to be very careful here with signs, and this is one way of ensuring that you won't make any problems for yourself. And I'll just reorganise that into something that maybe makes a little more logical sense. Okay, this one's a sum of cubes, and there is an identity for it, but it's not one that's particularly well known and used much anymore. But a squared minus ab plus b squared. So in the first bracket, it's a plus b. It's exactly the same as the sum of the cubes, sum being add. So this one is always positive. It doesn't matter if it's a sum or difference. And these two signs here are always opposite. That's a useful method for trying to remember that. So this is like our a cubed plus our b cubed is like 5 cubed is 125. So this becomes a plus 5, a squared minus I've really made a blur on that. That's b cubed plus 5, so this is b plus 5 outside of a squared, which in our case is b squared, subtract 5b plus b squared, 5 squared is 25. Okay, this is a trinomial that needs factorising. The first thing that you'll notice is that 2 is a common factor to all of those terms, so that's 6a squared plus 7a take away 3. And then we can go through the method of our AC and our B. So AC is equal to negative 18 and our B is equal to 7. I'll bring back the 2 later. So we're after two numbers that multiply to give minus 18 and add up to 7, and that would be 9 and minus 2. So that means that our 6a squared plus 7a minus 3 can be rewritten as 6a squared plus 9a take away 2a take away 3. Common factor with the first two is 3a outside of 2a plus 3. Subtract 1, a lot of 2a plus 3 is equal to, our grouping factor is 2a plus 3 and our other factor is 3a take 1. Now remember our common factor of 2, so what I might do is just write that. The final answer is 2 multiplied by 2a plus 3, 3a take 1.